Hello, viewer. Today we're going to be going over Chapter 4, number 14. A constant force applied to object A causes it to accelerate at 5 meters per second squared. The same force applied to object B causes an acceleration of 3 meters per second squared. Applied to object C, it causes an acceleration of 8 meters per second squared. Now, you may be wondering, which object has the largest mass? Let's figure that out using Newton's second law. Here we go. Force equals mass times acceleration. The equation for Newton's second law. But we're not trying to find force today. We're trying to find mass. So here's what we're going to do. Divide each side by acceleration, leaving, you guessed it, just mass, which is what we're trying to find. Now, you may be wondering, what's force? Well, up here it says a constant force. So you can use any number you'd like, as long as it's constant. I will be using number 1. Now, for object A, we're using 1 over, because we're using 1 as our F, and our acceleration is 5 meters per second squared. This leaves us with 1/5, or as a decimal, which equals our mass. Now, for object B, 3 meters per second squared. 1 again over 3 meters per second squared equals 1/3, or about 0.33. Now, for our C, 1 again over 8 meters per second squared. 1 over 8, or about 0.125. That equals our M. So, which object has the largest mass? Well, as we can see, object B. Out of these 3 values, object B has the largest mass. Now, you may be asking yourself, which object has the smallest mass? Well, as we can see up here, object C is going to have the smallest mass. Object C. Now, what is the ratio of mass A to mass B? Let's figure it out. Mass A, let's see, that's going to be our 1/5 over our mass B, which is going to be our 1/3. And now these are 2 fractions, so this bottom fraction can be flipped and is going to leave you with 3/5 is our ratio of mass A to mass B. Hope you found this helpful.